When you eat spicy food like chili peppers, your mouth suddenly feels like it is burning. But here is something surprising. Spicy food is not actually hot in temperature at all. If chili peppers are not physically hot like fire or boiling water, why does your brain react as if your mouth is burning? The answer involves a fascinating trick played on your nervous system. When you eat spicy food, your tongue sends warning signals to your brain very quickly. Your brain interprets these signals as heat, even though no real temperature increase is happening. The reason this happens is because chili peppers contain a special chemical compound called capsaicin. This molecule is responsible for creating the burning sensation you experience when eating spicy food. When capsaicin touches your tongue, it interacts with tiny sensors located inside your mouth. These sensors normally detect dangerous heat, helping protect your body from injury. These special sensors are called heat receptors, and scientists refer to them as TRPV1 receptors. Their normal job is to warn your brain whenever something hot touches your skin or mouth. But capsaicin has a unique ability to activate these heat receptors without any real heat present. As a result, your brain receives a signal that feels almost identical to actual burning. When your brain receives this signal, it assumes your mouth may be in danger from high temperature, so it reacts quickly by creating the familiar burning sensation that spicy food produces. This reaction is actually part of your body's natural protection system designed to prevent injury. Your nervous system cannot easily distinguish between real heat and chemical signals that imitate heat. Because your brain believes something hot is happening, your body responds by sweating and increasing blood flow. These reactions are the same defenses normally used to cool your body during real heat exposure.
Interestingly, the burning sensation from spicy food is not actually a taste at all. Instead, it is a type of pain signal detected by heat-sensitive nerves inside your mouth.
But if spicy food activates pain receptors instead of taste receptors, another question appears immediately. Why do so many people around the world actually enjoy eating food that feels like it is burning? Now here is something even more surprising about spicy food. If chili peppers activate pain receptors inside your mouth, why do millions of people around the world actually enjoy eating them? When your brain detects signals that feel like burning heat, it immediately activates protective defense mechanisms. One of these responses involves releasing special chemicals designed to reduce discomfort and stress. Among these chemicals are substances called endorphins, which act as natural pain relievers inside your body. Endorphins help reduce discomfort and create a feeling of relief after the brain detects possible danger. These natural chemicals work by reducing the strength of pain signals traveling through your nervous system. As a result, the burning sensation becomes more manageable and sometimes even surprisingly enjoyable. At the same time, your brain also releases dopamine, a chemical linked to pleasure and motivation. This reward signal encourages your brain to remember the experience as something exciting rather than harmful.
Because both endorphins and dopamine are released together, the brain begins transforming a painful signal into a pleasurable experience. This unusual combination explains why spicy food can feel intense but still enjoyable.
Scientists describe spicy food as a safe form of danger. It excites the brain without real harm. Your body reacts strongly, but your brain quickly learns that the experience is not truly dangerous. This reaction is similar to the excitement people feel when riding roller coasters or watching suspenseful movies. Even though the experience feels intense, the brain understands that the situation is actually safe. In many cultures, people begin eating spicy foods from a young age as part of traditional meals. Over time, repeated exposure teaches the brain to associate spicy sensations with positive experiences. As people continue eating spicy food regularly, their heat receptors become less sensitive to capsaicin. This process allows experienced spice eaters to tolerate stronger levels of heat than beginners. This growing tolerance explains why some people enjoy extremely spicy foods. Their nervous systems have adapted through repeated exposure. Too spicy. But this leads to another fascinating question about chili peppers themselves. If capsaicin creates pain signals in animals, why did plants evolve this powerful chemical in the first place? So why would a plant produce a chemical that causes such an intense burning sensation in animals? To understand this, we need to look at how plants survive in nature without the ability to move. Unlike animals, plants cannot run away when something tries to eat them. Instead, they must develop clever chemical defenses to protect themselves from being destroyed. Many plants produce natural chemicals that taste bitter, toxic, or irritating to discourage animals from eating them. Capsaicin is one of these defensive compounds designed to protect chili peppers from predators. When mammals eat chili peppers, the burning sensation quickly teaches them to avoid the plant in the future. This reaction helps prevent animals from damaging the seeds inside the fruit. Seeds are the most important part of a plant's reproduction process because they allow new plants to grow. Protecting these seeds gives chili plants a better chance of surviving across generations. Birds cannot feel the burning sensation of capsaicin the way mammals do. This allows birds to eat chili peppers and spread their seeds naturally. As birds travel long distances after eating chili peppers, they carry seeds far away from the original plant. This natural transport system helps chili plants grow in new areas and expand their population. This creates a perfect evolutionary strategy for chili plants to protect their seeds from mammals while still allowing birds to spread them widely. Capsaicin acts as a selective defense system rather than a random chemical accident. Capsaicin may also help protect chili peppers from harmful fungi that could damage developing seeds. This additional protection increases the plant's chances of successful reproduction in humid environments. In regions where fungal infections are more common, chili plants often produce higher levels of capsaicin. This suggests that spiciness evolved partly as protection against environmental threats as well. Chili peppers did not evolve their spicy chemicals to affect humans. Capsaicin was a defense strategy long before humans ate spicy foods.
But once humans discovered chili peppers, something unusual began happening inside the body. Spicy food started triggering reactions far beyond just the burning sensation inside the mouth.
When you eat spicy food, the burning sensation does not stay only inside your mouth. Instead, your entire body begins reacting as if it is trying to cool itself down from real heat. As capsaicin activates heat receptors on your tongue, signals quickly travel to the brain's temperature control center. This region, called the hypothalamus, helps regulate how your body responds to heat. When the hypothalamus receives these signals, it assumes your body temperature is rising dangerously, so it immediately activates several cooling responses designed to protect your body from overheating. One of the most noticeable reactions is sweating, especially on your face and forehead. Sweating helps release heat from the body, even though spicy food has not actually increased your temperature. Capsaicin also causes small blood vessels near the skin's surface to expand. This increased blood flow helps release heat from the body and explains why your face may turn red. Spicy food can also stimulate nerves inside your nasal passages, causing them to produce extra mucus. That is why your nose may start running shortly after eating something very spicy. In a similar way, capsaicin can activate nearby tear glands around your eyes. These glands release tears as part of the body's protective response to what it believes is irritation. You may also notice that people often breathe through their mouths after eating spicy food. This reflex helps increase airflow across the tongue in an effort to reduce the burning sensation. Spicy food can even cause a small increase in heart rate as your body reacts to the intense sensory signals. This response is similar to what happens when your body prepares for sudden physical activity. Together, these reactions form a coordinated cooling response across your entire body. Even though no real heat is present, your nervous system behaves exactly as if your temperature were rising. After repeated exposure to spicy food, your brain gradually learns that these signals are not truly dangerous. This learning process helps explain why experienced spice eaters react less strongly over time.
But not all chili peppers create the same level of burning sensation in your mouth. Scientists have developed a special way to measure exactly how spicy different peppers really are. Scientists have developed a special system to measure how spicy different chili peppers really are. This system helps compare the strength of capsaicin found inside peppers across the world. This measurement system is called the Scoville scale, and it describes the intensity of the burning sensation caused by capsaicin. The higher the number on the scale, the stronger the spicy effect feels. For example, sweet bell peppers contain no capsaicin at all, while jalapeno peppers produce a moderate burning sensation. Some of the world's hottest peppers measure millions of units on the Scoville scale. The strongest chili peppers ever recorded contain extremely high concentrations of capsaicin compared with everyday peppers. Even experienced spice eaters must be careful when tasting peppers at these extreme levels. When people eat very spicy food, their first reaction is often to drink water immediately. However, water does not remove capsaicin effectively because the molecule does not dissolve well in water. Capsaicin behaves more like an oil than a water-based substance, which allows it to remain attached to your tongue. That is why drinking water often spreads the burning sensation instead of stopping it. Milk works much better because it contains a protein called casein that helps break apart capsaicin molecules. This process allows the burning compound to wash away from your tongue more easily. As casein removes capsaicin from heat receptors inside your mouth, the burning sensation begins to fade. This is why dairy products are one of the most effective ways to reduce spicy discomfort. Over time, humans across many cultures began using chili peppers as an important ingredient in traditional cooking. Today, spicy food plays a central role in cuisines across Asia, Africa, and the Americas. Scientists have also discovered that moderate amounts of capsaicin may support metabolism and circulation in the body. These possible benefits help explain why spicy food remains popular across many different cultures. So even though spicy food feels like heat, the sensation actually comes from chemical signals interacting with your nervous system. Your brain creates the burning experience even though no real temperature increase occurs. The next time you taste something spicy, remember that your brain is reacting to a clever chemical illusion. What feels like fire in your mouth is actually one of nature's most fascinating sensory tricks.